Assalamu alaikum everyone. My name is Muhammad Amin. Today I am here to solve the simple paper solution of Skoltech scholarship test. The question is from classical mechanics and from the simple paper of mathematical and theoretical physics. Consider an anharmonic oscillator with a Lagrangian function of L x dot is equal to the x dot square by 2 minus omega square x by 2 minus alpha x power 4 plus beta x into x dot square. Then find the Hamiltonian function for this system. We have a Lagrangian function and we have to find the Hamiltonian function for the system. Okay, we know a well-known formula that Hamiltonian function of a system relates with the Lagrangian function. That is, Hamiltonian function is equal to the velocity coordinate into partial by partial velocity coordinate of the Lagrangian minus Lagrangian. Okay, now here we have to first find this one, the partial by partial velocity coordinate of the Lagrangian. So here the position coordinate is equal to the x and the velocity coordinate q dot is equal to the x dot. Now by placing x dot and q dot with the formula, it gives us Hamiltonian is equal to the velocity coordinate means x dot partial by partial velocity coordinate of Lagrangian minus Lagrangian. So first we have to find the partial by partial velocity coordinate of the Lagrangian. Now the partial by partial of x dot of Lagrangian is equal to the partial by partial x dot. This is the given value of the Lagrangian. So by taking the partial derivative, it gives us, the first term gives us x dot because the power comes in front and it cancels out with the 2. So it gives us x dot. By taking the derivative, the partial derivative of this one, here the x dot means the velocity coordinate is absent. So the constant derivative is 0. It gives us 0. And in the third term, as it is, the velocity coordinate is absent and its partial derivative is 0. Now in the last term, we have bx x dot square. So b and x here are common, so it comes out from the differential. And now this differential applied with the x dot square. By applying this, the 2 comes in front and again derivative of the x dot partial by partial x dot into x dot, it gives us 1. So the final result will be 2 beta x dot. Now the partial by partial x dot means partial by partial velocity coordinate of the Lagrangian is equal to the x dot plus 2 beta x into x dot. We have to place now this value in the original formula. So by placing this in the original formula and also placing the Lagrangian function as it is here, so by multiplying it with this one, so it gives us x dot square plus 2 beta x dot square, and the minus multiplied with the Lagrangian function. When minus multiplied, it gives us minus x dot square by 2, and this will become positive, this will become also positive, and the final term become negative. Now we have to arrange the equation for same terms. These two are same terms and these two are same terms, and we have to write these two terms as it is. Now by arranging this one, it gives us 1 minus 1 by 2. It's 1 by 2 of x dot square, so it gives us x dot square by 2. And here 2 beta x are common. 2 beta x dot square are common. No, okay. It's like 2 beta x dot is there 2 times. And the single time beta x dot is there. So 2 minus 1. It gives us 1. So it's become beta x dot square. Here it's not x dot, it's x dot square. And these two terms, final terms, remains as it is. So this will be the Hamiltonian for the anharmonic oscillator system if the Lagrangian of the function of the system is this one. So this was it. Finally, thank you. Allah Hafiz.